We spend a massive amount of time locking the digital front door. We use 20-character passwords, facial recognition, and multi-factor authentication codes. But a hacker doesn't always need to pick that lock. They can bypass the entire security apparatus with a single line of text. If a system explicitly requires a password and a physical authentication app on your phone, how does an attacker get full access to your account without ever touching either of them? The answer lies in the stateless architecture of the web. The internet runs on HTTP, the foundational system for loading web pages, which inherently forgets who a user is after every single page load or click. If the internet couldn't remember you, you have to retype your password every time you liked a post or opened a new tab. This created a massive usability problem, leading to a workaround that has become the web's greatest vulnerability. To solve this problem, servers issue a session ID, also known as a cookie. Think of it as a temporary digital ID badge stored in your browser after you've successfully logged in. This loop keeps you logged in. Your browser automatically hands this badge back to the server with every click. But there's a critical flaw. The server only verifies the badge, not the user. If a hacker sends that identical string, the server accepts it. If a hacker copies this text file, they completely bypass the authentication phase. To the server, the person holding that cookie is the user. Attackers have several ways to steal these badges. The first is packet sniffing, or hijacking, which typically occurs on unsecured public Wi-Fi networks. Because Wi-Fi travels over radio waves, an attacker can intercept the unencrypted signal. They essentially pluck the session token directly from the data stream before it even reaches the server. The second method is cross-site scripting, or XSS. Here, the vulnerability isn't the network, but the actual code of the website you're visiting. In an XSS attack, an intruder injects malicious JavaScript into a web page. When you load that page, the script quietly reads your internal cookie file and emails it to the attacker in the background. Because these exploits occur silently, a user's session can be hijacked without them ever falling for a phishing scam or making a visible mistake. A more modern and highly prevalent method involves malicious browser extensions. These often masquerade as helpful tools, like ad blockers or productivity apps, to gain a foothold on your machine. Once installed, these extensions abuse their permissions to scrape the browser's local storage. They quietly copy active session IDs for major platforms like Google, Slack, or Instagram and send them to the attacker. The final step of the heist is surprisingly simple. The attacker manually injects the stolen text string into their cookie editor. When they refresh the page, the server reads the hijacked cookie, welcomes the attacker back, and grants them total control over the account. It's a bitter irony. The Remember Me feature, designed for your convenience, is being weaponized to turn your own browser into a backdoor. Modern hackers explicitly target cookies because they know that brute forcing a 20-character password or a rotating MFA code is nearly impossible. This photographic evidence from a high-level EU video conference represents the extreme stakes of these sessions. In 2020, attackers used Zoom bombing techniques to exploit insecure session settings, hijacking private corporate environments and government meetings. Since then, we've seen a 2019 Slack vulnerability expose session cookies, and 2025 browser-in-the-middle attacks steal sessions in seconds. Even top-tier enterprise platforms struggle to defend against direct token theft. Today, session hijacking has evolved into the primary vector for bypassing enterprise-grade security globally. To fight back, cybersecurity experts have deployed invisible shields to protect the stateless web, starting with HTTPS. This diagram shows how HTTPS and HSTS protect your data. By forcing the connection into an encrypted tunnel, they turn your data packets into scrambled noise, rendering Wi-Fi sniffing useless. Developers also use HTTP-only and secure flags. These are code-level rules that strictly forbid JavaScript from reading your cookies, which effectively kills most XSS attacks. Finally, systems use session rotation. The server constantly issues a new ID badge every few minutes, causing any stolen tokens to expire before a hacker can use them. Ultimately, true security requires a shift in how we browse. It requires logging out of sensitive sites and auditing our browser extensions, because an active session can be just as dangerous as a stolen password.